Sir.
Um,
Yes. So I'm going to record this session. So maintain dignity and thank you very much for joining in this early hours. And yeah, so coming back to the stem cells. So we are discussing about stem cells, their applications, and many of us even don't know what are stem cells. So I will start with very basics about, I will tell you like you are a small kid, maybe like a fourth standard. So it will be very interesting. See here. So yeah, so what are stem cells? Stem cells mean students. Here you can see, right? So this is a chicken. So how chicken came? So there is a egg, right? Yes, chicken came from an egg. Please mute yourself, others. Everyone mute. I will mute everyone, okay, in between. So there is some accidental unmutes. Anyway, see here, students. So as I stated previously, egg is a stem cell actually, right? It is a very big stem cell. So what happens in the egg? If you keep egg for 21 days in a right temperature, the cells in the egg will be converted to, they will be matured to various tissues and the tissues will become a life like a chicken. That's what he is saying. So the process of conversion of egg into chicken shows the potential of stem cells. It is the stem cell that are present in the egg that are responsible for making us alive, right? So yeah, many of us know omelette. Yes, omelette is just a stem cells. Omelette is our regular diet, so we are having stem cells as a diet by omelette. So now you can understand, right? Anyway, this lecture is not about omelette. This is about the stem cells. So the idea that I was trying to make in this lecture is uh, how the egg converted to this beautiful chicken with this complicated tissue, cells, eyes, all these feathers, everything. Even feathers are cells. All these cells are embedded in that yolk sac only. So how yolk sac converted to these tissues is the story. That is the story of stem cells. So yes, so see here, students. So I hope you can see here. Let me turn on the laser. See, listen. Whenever the egg must be fertilized, the egg will be fertilized by entering an sperm into the egg. Okay. Once the sperm and the ovum combined, it will make a zygote. That is the first birth of life. A zygote has been formed. That will be a big cell, and that cell will start dividing. Right, that first formed cell is a stem cell. The cell that is formed initially once the sperm and ovum has united, that is a stem cell. Now this stem cell will be converted to many types of cells, right? So that zygote or blastocyte will be converted to various types of cells in the body. Okay, that is the idea of stem cells. Now listen, I will give some terms and these terms are very important. One term is stem cells has two properties. There are two properties to the stem cells. So those properties are, they have self-renewal property and differentiation property. Differentiation means conversion of one cell to another type of cell is called as differentiation. A stem cell converted to red blood cell, a stem cell converted to white blood cell, that is called as differentiation. And second property is self-renewal. A stem cell will be converted back to a stem cell. Okay, so these are the two properties of stem cells. One is self-renewal, that is a stem cell to a stem cell, and second one is differentiation. Conversion of stem cell into other type of cell is called as differentiation. It is the differentiation property of these stem cells that is giving them the unique celebrity status. Okay, that differentiation is also called as plasticity. Okay, there are multiple terms we are using academically. It can be said as a plasticity or differentiation. So plasticity means it is the ability of the cell to transform into various types of cells is called as plasticity or differentiation. So this is the primary properties of stem cells. Only two properties. Self-renewal property, a stem cell will become another stem cell. And the second one, it will be differentiated into a separate cell, okay, a specialized cell. It can be a red blood cell or muscle cell, right? So now you understood what is a stem cell, then you understood the properties of stem cells. Then let us see the basic definition of stem cell. So what are stem cells? Stem cells are undifferentiated. Okay, the meaning of differentiation means conversion of to other cell. When it is not differentiated, that is called as undifferentiated. So stem cells are undifferentiated cells that has the capacity that have the capacity to differentiate into multiple types of cells. Believe it or not, a single stem cell can be divided into 200 various types. Okay, that means we are just a combination of 200 various types of cells. That's it. The 200 various types of cells can be a nephron cell, sperm cell, liver cell, bone cell, kidney cell, hepatocyte, lung. So yeah, we are a combination of 200 unique type of cell sets. How the stem cell has transformed into these 200 cells is the story of this entire lectures actually. Okay, so yeah, the stem cells has been converted to various types of cells in the body. So by this we understand that why we are studying the stem cells. Maybe when we have any damage in the body, shall we use stem cells to regenerate that damage? Shall we use stem cell like a cement? Okay, imagine a building as a body. So can we use stem cells as a cement to mold the cement into that particular cell? I have a liver problem. I will take a liver stem cell. I will keep liver stem cell in my body, and I should get a new liver. I have an issue with my bone marrow. Maybe I got some leukemia, some blood cancer. Is it possible to give a new stem cells in my bone marrow? Can I keep new stem cells in my bone marrow so that my cancer cell will be removed and I will get a new blood cells? Okay, that is the idea behind studying these stem cells. Okay, we are trying to see some therapeutical aspects, some curing therapeutical aspects of these stem cells. Can we able to use stem cells for therapy? Say for example, a patient has a sickle cell anemia. So maybe in this sickle cell anemia patient, the stem cells itself have an issue. The stem cells have sickle cell gene, and this gene causing sickle cell anemia in the patients. Can I replace his stem cells? Can I replace his sickle cell stem cells with a normal red blood cell stem cells? Is it possible? Yeah, that's what we are trying to address in this lectures, right? So now you understood what is stem cell. Now you understood the properties of stem cells. There are two properties: self-renewal, that means converting to another stem cell, and second one, differentiation. Converting into a different type of cell is called as differentiation. So these two properties we understood, and the role of stem cells we understood. Then let us see some embryonic development. We need to understand how an embryo developed. Then only we will understand the stem cells. Okay, very, very important topic. Listen properly, students. See, uh, I will show directly. So there are, I want to tell you a story. Then you will understand this development. Uh, Listen, we want to build a building. We need to construct a building. Then I need some workforce. Okay, some specialized workforce. I need a labor that can able to build the building. I need an engineer. Okay, engineer might have different types of engineering. I need an electrical engineer. I need a civil engineer. I need a any other particular specialized engineer. I need an engineer. I need a labor, and I need some supervisors. Okay, supervisors that will overall survey, overall observe my building structure. So I given three types of people: labor, engineers, and the other one is supervisors. Now, engineers themselves have multiple branches. Electrical engineer will take care of electricity of my building. The civil engineer will take off structure of my building, and the other types of engineers will take off various types of engineering aspects of my building. So now I know engineers. Then I have labor. Now in my labor also I have various skilled labors. One labor can able to do cementing of my building, and another labor can able to do the drain system of my building. Okay, drainage and sewage system of my building. And another labor is very good at transporting things. So now I have labor, I have engineers, and I have third category that are supervisors, various types of supervisors. Labor supervisors, engineering supervisors, overall constructing supervisors. Okay, so when I give my work to these three category people, they will take care of my building. They will give me a complete constructed building. A complete constructed building is a developed fetus, a baby, right? Similarly, these cells will go to three lineages. Once the sperm binded with a ovum, they will take three important lineages, and these three lineages are called as, I will show here, ectoderm, mesoderm, and endoderm. There will be three types of cells in a blastula in an embryo. They are ectoderm cells, mesoderm cells, and endoderm cells. Are you following, students? Are you listening to me?
Yes, sir.
Everything clear, right? Yeah. So now I said
Sir.
the cells has taken three important work: endoderm cells, mesoderm cells, and endo, ecto, and mesoderm cells. Let us see what these cells will do. See, these are stem cells only. Keep in mind, this is not a complete baby. This is just a ball you can see here. But how this ball becoming into a baby? How these three types of cells present in this ball making into a baby? Ball is not right word, but I'm giving for ease of understanding. So these three types of cells made a fully developed baby. Let us see how does it happen. Okay, see, the ectoderm, the ectoderm category of cells, the ectoderm category of stem cells will make skin and nerve cells. Okay, ectoderm will give skin and nerve cells, and mesoderm will give bones and muscles, and your endoderm will give liver and thyroid. That means we have three types of holes. Okay, we are deuterostomes. Okay, we have a nerve tube. Skin and nerve is one type of stem cell origin. Then muscles and bones are one type of stem cell origin, and liver and thyroid came from endoderm. So these are the three types of stem cells we have. So with this understanding, let us go to the next hierarchy of complexity of stem cells. Now, these stem cells are simply categorized into four types: totipotent stem cells, pluripotent stem cells, multipotent stem cells, and unipotent stem cells. This is very important topic. Pay attention. Totipotent stem cells means that is our sperm and zygotes. Okay, sperm, ovum, and zygote are totipotent. That means these stem cells can transform into any type of cell in our body. They can transform into either liver, skin tissue, anything. All body is possible with totipotent stem cells. Then pluripotent stem cell. Pluripotent stem cell became a specialized now. They have a, totipotent is like a multi-set skills, whereas pluripotent are specialized. Pluripotent stem cells are three types. Okay, pluripotent will take either ectodermal pathway, mesodermal pathway, or endodermal pathway. That means you are understanding, right? Ectoderm will give skin and nerve tissue, mesoderm will give skeletal and bone tissue, and endoderm will give the gastrointestinal tissues. So such stem cells are called as pluripotent stem cell. I will give one example of pluripotent stem cell: hematopoietic pluripotent stem cell. Hematopoietic pluripotent stem cell can able to make any type of blood cell. A hematopoietic pluripotent stem cell can able to make RBC, WBC, platelets, including WBC types, okay? Granulocytes, agranulocytes, neutrophils, basophils, everything can be done by a hematopoietic pluripotent stem cell. So similarly, we have pluripotent stem cells. So now you understood that pluripotent stem cells are, they will take any one of these three lineages. Either they will take a ectodermal lineage, mesodermal lineage, or endodermal lineage. So now you understood what is pluripotent stem cell. Then multipotent. A multipotent stem cell is categorized into another special skill. A multipotent hematopoietic stem cell will only make blood cells. A multipotent neuronal stem cell will make only neurons. A multipotent mesenchymal stem cell will make only bones and tissues. Okay. Now they are becoming more specific in nature. That is multipotent stem cells. That means the capability of transforming into various types of cells was shrinking now. They are becoming more specialized. Okay, that is multipotent stem cells. Then you have a unipotent stem cell. And unipotent stem cell example will be erythroblast. Erythroblast is a stem cell that will only be converted into red blood cell. That's it. Leucoblast will be only converted into white blood cell. Neuroblast will be converted into neural cell. That means these are only one type of differentiating unipotent stem cells. They will only differentiate into one type of cell. That's it. Erythroblast will be converted to red cell, red blood cell. Leucoblast will be converted into white blood cell. So yeah, these are the four types of categories of stem cells: totipotent stem cells, pluripotent stem cells, multi and uh, unipotent or lineage committed stem cells. Okay, so is there any practical use of understanding the stem cells? Say, for example, I got a patient and patient has a severe anemia. I came to know that his bone marrow has been died. The bone marrow not functioning. He has aplastic anemia, which is a very deadliest form of anemia. That is also a cancer. Bone marrow was not at all working. That means my patient cannot have his own blood cells. In that conditions, can I take some others bone marrow? I know that their bone marrow will have stem cells. Can I transplant then their stem cells to my body, to my person, to my patient? Can I transplant some others stem cells into my patient so that my patient can able to generate his blood cells? Okay,
Yes.
yeah. That is the idea behind these stem cells. Now there is an issue, students. The issue with this transplantation is, listen, we all have immune system. Okay, when I'm taking my, when I was receiving a tissue from other person, my immune system will reject it. My immune system will reject the donor's blood or donor's tissues. This is one hardest problem in immunity or in transplantation medicine. The problem is the other person tissue will rejected by the second person. Okay, the receiver immune system will reject the donor cells. That is one huge problem. That's why where our stem cells will come into action. What I will do is, for example, in my patient, I will collect his own stem cells. I will see whether one or two stem cells are alive or not. If I have a good cells in my patient, I will take his healthy stem cells, I will divide them, and I will retransplant into his own body. I'm taking my own patient stem cells. I nurtured them and I reintroduced into the body so that they will get their stem cells will take care of their body. That is the idea behind umbilical cord stem cells. In umbilical cord stem cells, what we are doing is when we burn, okay, when our mother given birth to us, we have a umbilical cord. Our belly button is connected to a tube, and that tube is connected to the mother by a placenta. The tube has stem cells. So the idea is I will preserve my umbilical cord stem cells. When I was baby, I have preserved my cells. Okay, my parents preserved the cells. In the future, if I get any issues in my body, I can use my stem cells. Okay, I can use my stem cells so that I will be recovered from the injury. My stem cells will repair my own cells. Okay, that is why these stem cell banks arrived. And our ma'am, Dr. Anuradha ma'am is a she's working in a stem cell bank. Okay, blood stem cell bank, and she's an expert and specialist in preserving umbilical blood actually. Okay, she knows how to preserve these stem cells, how to isolate stem cells, and how to use these stem cells for blood related therapies. Ma'am is only focusing on hematopoietic stem cells, and ma'am won't touch other stem cells like neuronal cells and other types of stem cells. They are under research actually. Even we don't know how these stem cells are working, how they are communicating each other, how they are differentiating, how they are maintaining the colonies, how they are interacting each other, how they are sustaining a life. These are really a mysteries in the medicine. Even though we are studying medicine for past 100 years, because we are a product of 4 billion years of evolution, right? So yeah, but there is a very good understanding in the area of hematopoietic stem cells, and we understood how these hematopoietic stem cells are interacting, and there is a safe treatments available because of our immense understanding and understanding of these hematopoietic stem cells. So this is one area. Then let us see. Actually, this topic is about hematopoiesis, students. So I will focus on hematopoiesis now. See, a quick summary of types of cells. Totipotent, that is the baby cells, sperm cells, and ovum. Then pluripotent stem cells, they will take these three lineages, mesoderm, ectoderm, and endodermal lineage. Then multipotent, they can be, mesenchymal neuronal. Then unipotent, they will be differentiated into a single type of cell. That's it. Then, yeah, this is the same thing. The same thing I said, right? From embryo, they are taking multiple lineages and they're making all types of cells in the body. Yeah. So coming to the hematopoiesis, the best textbook I like for studying hematopoiesis or erythropoiesis is Shembulingam. So I have this beautiful flow chart in Shambhalingam. In this Shambhalingam, they have very clearly said, see, uncommitted pluripotent hematopoietic stem cell has been committed. Now it is committed to pluripotent hematopoietic stem cell. That means it will make it will make blood cells. Now this committed pluripotent stem cell has taken two important colonies. One colony is blastocyte colony and other one lymphoid colony. Lymphoid colony made lymphocytes, whereas colony forming blastocyte took three lineages. They took colony forming erythrocyte, leading to red blood cells, colony forming granulocyte monocyte, leading to neutrophil, basophil, and eosinophil, and monocytes, and colony forming unit megakaryocyte. This will give the platelets. See how a single committed pluripotent stem cell given rise to all types of blood cells in the body. This is the beauty of stem cells. Okay, I just need to take care of this pluripotent stem cell, and this pluripotent stem cell will give all types of cells in my body. Even if I have thrombocyte issue, I have platelet issue, monocyte issue, neutrophil issue, red blood cell issue, or lymphocyte issue, or antibodies, anything. All these problems can be addressed if we safeguard the stem cell. That is the idea of stem cells. Okay, so yeah, see, this is how the various types of stem cells, hematopoietic stem cells has taken their lineages to become into a terminally differentiated cells. By the way, this is a new word to you. Ultimately, final matured cell is called as terminally differentiated cell. Ultimate final matured cell is called as a terminally differentiated cell. So these are terminally differentiated stem cells. So the fourth semester students, they will understand. Yesterday, Diksha asking me a question when I was taking a lecture on a leukopoiesis, that is a cancer. I was discussed about teratoma. Teratoma is a type of a cancer where there will be a tumor in an intestine or anywhere in the body, and the tumor will have eyes, eyes, hair, teeth, everything will be there to a tumor. How the tumors formed means actually they are the stem cells of that particular lineage. Maybe I got a cancer to a mesodermal stem cells, and mesodermal stem cells can able to make a particular types of cells, right? Skin, hair, neurons. So they all clumped together to form a teratoma. Okay, so teratomas are an outcome of problem with the stem cells. A cancer to stem cell lead to a teratoma formation. So that teratomas I will discuss in the future lectures. Very interesting topics. So yeah, this is all about the stem cell students. Now I need to raise my concerns. The concerns about using stem cells. Listen students, very important. Listen, my parents are not so rich and they didn't preserve my umbilical cord blood cells in the bank. So if today I got any issue, I don't have my stem cells stored in a bank. Is there any shortcut pathway? Is there any alternate pathway to get my stem cells? There is an alternate pathway. That is, let me take, okay, my sperm cell and let me make a clone. I will take my own sperm cell, I will take a woman ovum, I will remove her genes and I will make a clone in a petri dish. I was fertilized my own sperm in a petri dish and it became into a totipotent cells. It became a small embryo. In a petri dish, it became a small embryo. Now I will cut the embryo cells because I know that that embryo has totipotent stem cells, and those stem cells are my own origin because they are my own chromosomes, right? My own sperms, my own genes. So can I use my own embryo for my therapy? Is that ethically good? This is the baddest consequences of or misuse of stem cells. There is a chance of baby murdering. Ethical problems will be more in stem cells. See, I was giving birth to a small embryo and I killed the embryo and I took it. You just imagine the consequences. It can people might make a small babies and they will keep them as a as a stock. They will keep as a plan B. If anything happened to me, I have my baby Vamsi somewhere and I will kill him. I will take his heart. Yeah, this can be easily misused. This technology can be easily misused when it is not in the right hands. Or else we can bring back Mahatma Gandhi, we can bring back Hitler, we can bring back all the dictators or all bad dust or anyone. there won't be a, there won't be a logic of individuality. There won't be a logic of individual will. All these things will be bypassed when this particular technology is exploited. So there should be many safeguards, and this should be tightly regulated. This should not be going to the normal hands. There should be stringent policies in usage of stem cells. To what extent we can use stem cells and what stem cells we should not use. Can I genetically engineer my baby by taking my stem cells? Can I make a white Vamsi? Since I'm black, I want a white Vamsi. Can I make it? These things are possible. These things are possible when we are exploiting these technologies. Right. So these things will be addressed in the future lectures. How to tightly regulate these stem cells, how to take, and there are multiple things, how these cells are communicating, how they are differentiating, what environmental factors causing them to change their behavior. There are scenarios where a skin cell will be converted to neural cell or neural cell will be converted to skin cell. Who is telling them? What are the triggers? How the genes came to know that they want to differentiate now? What are the switches in the genes responsible for making a full grown baby? All these things will be addressed in the future classes. Thank you very much, students. I hope this is fascinating and this is interesting. This might elicit curiosity among you. Am I correct? Yeah, this is all about stem cells in a nutshell. There are very interesting things.
Yes, very
Yeah.
interesting.
Any doubts now? We can have, only one
No,
minute.
no, sir.
Yes, John.
It's very interesting.
Yes, yeah, this is really interesting. That's why we have included stem cells as a VAC course. So you will understand. You can work in stem cell bank. One of my senior, he's working in a G1 stem cell that is in the south part of India. That's a yeah. He's getting very handsome salary. Yeah, we
Yeah,
the lab
sure,
technicians we are eligible to work in stem cell banks. So
sure,
there are
sir.
multiple career opportunities in this area. Yes. Any more doubts?
No, no.
Yeah. So the other aspects of stem cells, their therapies we will address in the coming sessions. Okay. Please stay connected and please join regularly. And
Okay,
yeah,
thank you,
please fill
sir.
the
Appreciate.
attendance sheet and we'll see. So there is a Mrs. is saying if an adult has defects that require introduction of stem cells in his body, then he stored embryo. How sure are we that those stored embryo cells will not